in the last class we have mentioned about the different properties of penicillin and also the kind of quality we require when you try to produce penicillin from um, different substrates, and also when you use different kind of organism, then also you have chance to get different impurities. So in a nutshell, when you try to get this antibiotic produced by any fungi or bacteria, you make sure that you are not getting any contamination, or even if you get any contamination, that contamination should be separated very easily. That means you need not to spend too much of money for downstream operation, and also you need to make sure that downstream operation, whatever you do to recover the antibiotic, should not destroy the antibiotic. So whenever you use any such downstream operation process, you have to make sure that the downstream operation process is actually not degrading the antibiotic, and also you need to produce antibiotic in such a way that it should show minimal allergic allergic reaction to the user, and if possible you will try to produce a salt which is stable at acidic condition, because then you will have easy administration of that particular document, sorry, that particular material or antibiotic. So oral medication is only possible if your medicine is stable at low pH or acidic pH. And we have also mentioned about two different strains. Like earlier, when Alexander Fleming discovered penicillin, then he got it from Penicillium notatum. But in industrial scale, we try to produce penicillin using Penicillium chrysogenium. Now, yield of antibiotic is also another important parameter that also we have discussed in the last class. So most of the cases, you just use mutated strain, and the different kind of mutant will also have different capability to produce at a different titer or different concentration of antibiotic. But you have to make sure that the mutant strain is actually, or mutated strain is actually stable enough to reproduce your production batch after batch. Now, in the fermentation process, we have also mentioned lactose is the preferred substrate, and when you try to see the preference, then lactose show maximum preference. Like this Penicillium chrysogenium will prefer lactose over sucrose over glucose. And industrially, to reduce the cost of operation, instead of using pure lactose or sucrose or glucose, we use corn strip liquor that we can get from brewer industry, and this corn strip liquor will have sufficient amount of carbon, nitrogen, and also few precursors of penicillin G. Means you will actually provide certain aromatic compound, phenylamine or uh, phenylalanine. So otherwise, you have to add phenylacetic acid. So this precursors will actually help you to get benzyl penicillin or penicillin G. And we also showed that in the penicillin, this R group can be replaced by this penicillin benzene ring, or you can have straight chain. And when you have replacement of this R group, you actually essentially end up by getting different derivatives of penicillin. So penicillin G is one of the common penicillin we use for production, or you can have penicillin O, penicillin F, penicillin H, just by changing this R group. Now, we have also mentioned about the, and just 1 second, I'll come back and say. So we have also mentioned about Oxford unit, because in antibiotic production, instead of expressing the concentration in milligram or kilogram per liter or kilogram per meter cube or milligram per liter, we use Oxford unit, and one Oxford unit is equivalent to 0.6 microgram. And accordingly, you can actually get the concentration if you get the volume of the broth. So this production process requires certain amount of pH, because this particular fungi has the optimal pH range of 6.8 to 7.4. And for adjusting pH, we in industry they use sterile H2SO4 and NaOH solution. So if you need to reduce the pH, you add H2SO4, and if you need to increase the pH, you just use NaOH as alkali solution. And for production, optimal temperature is 25 degree plus minus 0.5 degree centigrade. And the same temperature is actually maintained in developing the culture, like in the seed vessel also, or inoculum preparation system also, you use similar temperature and similar pH. And even large scale fermenter also, you'll have similar kind of environment you try to make. And when you use constrip liquor, you are actually getting some precursor. But if you need to use this lactose or sucrose or glucose, any other media, defined carbon source, you actually add small amount of phenyl acetic acid. So that phenyl acetic acid will provide the benzene ring. So then it will help production of penicillin G. So at the end of the operation, you will get penicillin G. So when you see the production process, it also has substantial amount of steps for inoculum preparation. So you start with a slant grown on agar media, and then agar plus some solid. Agar is the solidifying agent, but you also have some other media to grow that on slant, and then you transfer it to the sec flask. So in a 500 ml sec flask, you maintain 100 ml, because you need to give substantial amount of headspace, because you are trying to get aerobic fermentation, and you maintain at a higher RPM to get good mixing, and also uh, dissolution of oxygen from headspace air. So you maintain at 250 RPM, 25 degrees centigrade, and you grow them for 4 days. So initially for inoculum preparation, in the smaller volume, you need to keep it for 4 days. Then the entire volume you transfer to 2 liter, 4 liter reactor, where working volume is 2 liter. So the reactor volume is 4 liter, but working volume is 2 liter. There you keep for 2 days. But in this system, again, this is a big vessel only. So it can, you can keep it in the shaker incubator, because this system doesn't have any stirrer inside. So essentially, you transfer the liquid from 500 ml flask to 4 liter flask, where working volume is 2 liter, and keep it for another 2 days in the same similar incubator. So essentially, you're maintaining 25 degrees centigrade, and also you try to maintain pH in the range of 6.8 to 7.4. Then to transfer that entire 2 liter liquid to a big reactor, it's 800 liter reactor, and their working volume is 500 liter. And there actually you get stirrer for mixing, and also you have other controller to adjust pH, temperature, and if you need to add any other media component, then also it is possible. But ideally, for all these steps, you actually work with batch system. So you add everything at the beginning, and then just wait for the batch time. That's why I'm talking about these different days. Now, there also you grow them for 3 days, and after growing them for 3 days, you transfer that entire volume to the production fermenter. So production fermenter capacity, say about 250,000 liter is the reactor volume, and working volume would be around 1.8 lakh liter. So in that reactor, obviously, when you increase the size, major challenging engineering challenges would be maintaining similar homogeneous condition. So transfer phenomena, whether it is heat transfer, mass transfer, in all transfer processes will actually have severe impact when you try to increase the sizes. So in production fermenter, you keep it for 5 to 6 days, and there you add small amount of phenyl acetic acid. even if you use even if you use constip liquor as your carbon source, still you add a little bit of phenylacetic acid just to make sure that the production of penicillin G is there at the end of the system. Means at the end of the process, you actually get penicillin G. And after doing the fermentation, you remove the just take out the entire fermented broth. Here, actually, the penicillin is dissolved in the liquid phase. So you need to separate the solid biomass, that is the fungal biomass, you need to separate. So you do filtration and then you work on the filtrate because your antibiotic is present in the filtrate. So you after separating the filtrate, you need to extract the compound using appropriate solvent. So in multiple extractor, you use different solvent mixture. So in the first stage, you use amyl acetate and butyl acetate. And there, the major component, which all the antibiotic will actually come into amyl acetate. And then from amyl acetate, you go to another extractor, second round of extractor, where you extract the antibiotic using phosphate buffer solution. So in all steps, you are actually using sterile solution. Now, with phosphate buffer solution, if you extract, then finally you end up by getting a potassium salt of penicillin. And this crystal, whatever you get, that also require further processing because you need to remove moisture for long storage. And also, if you have any other impurities, then also you need to use certain separation technique to remove those impurities from the potassium penicillin G slurry. So this crystal is actually formed in the buffer solution. So you end up by getting a slurry. Then you centrifuge or dry to remove the liquid, and finally the solid you get that you use for production of penicillin G, and you pack it in an appropriate manner to get a different formulation. So if you want to get only tablet, then you just pack them to get tablets. If you want to get capsule, or if you want to get suspension, then also you can get oral suspension. And in the last class, I also mentioned when you use any medicine as oral medicine, you always try to check acid stability and also allergenicity, because if it is showing any allergic reaction, then also people will not show interest to buy that. And resistance to penicillin inactivating agent is also an important factor, and that is true with any other antibiotic. So whenever you produce any antibiotic, you have to make sure that this antibiotic is effective against the specific bacteria. So here you can see multiple stages are there. You get slant to flask, then you have a bigger reactor. So these are all part of the upstream process. Then you get production fermenter, and from production fermenter you use rotary filter to remove the solid, and then the liquid filtrate will go to one extractor where you use amyl butyl acetate, that is extractor 1 or extraction unit 1, and then you have purification step. So you just try to purify this amyl acetate by using some filter, because you make sure that you are not getting any other solid residues. Then you have another extraction unit. There you just try to extract the amyl butyl acetate and add phosphate buffer. Sometimes in that extraction unit you just add phosphate buffer, or you can have another additional chamber. So this extraction 1 and extraction unit 2, they can do same job. Means you just do one set of extraction using amyl or butyl acetate, and you still believe that still some portions are remain. So you do second level of extraction using amyl butyl acetate if it is required. Otherwise, in the second extraction device, you just add phosphate buffer. But if you feel you need to do extraction operation with amyl and butyl acetate solution, then you can actually do the addition of phosphate buffer in a separate additional tank. That's called phosphate dosing tank. And then you have this third extractor where you actually have the phosphate buffer solution, and finally from that extractor you get the solid potassium salt of penicillin or potassium penicillate, and then that potassium salt will go through different downstream operation where your objective is to remove the moisture. So you'll have vacuum seal to, because I mentioned these are all temperature sensitive materials, so you cannot use normal drying operation. So this vacuum sensitive material will be there. Just 1 second. So the crystal, whatever you get, that actually filter through multiple ceramic filters. And every time when you use a ceramic filter to remove different other impurities, there you also incorporate a washing system. So after filtration, whatever crystal you'll get, you'll wash them in wash tank. And mostly water or buffer solutions are used in the wash tank. And then it will again go to another round of ceramic filter. And then finally, you just do vacuum drying, and then you get the crystalline potassium penicillin. So that is the extract of this entire production process. Only thing is, if you know about one particular antibiotic production process, then you can actually get reasonably good idea about other antibiotic production process also, because there's reactor as well as downstream of the equipment used in downstream operation or also in upstream operation may vary little bit, because obviously based on requirement you will use the reactor as well as other equipment used in downstream and upstream processes. But the grand scheme is almost similar. Like you need to spend substantial amount of time for production of inoculum. So you will have multi-stage for inoculum preparation, and then you will have fermenter, and after fermenter you will have separating system to remove biomasses from the liquid, and then you will follow extraction. So obviously the solvent will be different when you have difference in antibiotic, and then remaining downstream operation process will be very similar. So in ceramic filter, sometimes they may use certain specific ceramic material to absorb certain component present in the slurry, like some impurities which are some certain pigments or some other compounds which are not desired in the final product, that will also get separated in the ceramic filter. So ceramic filter is not only working as a mechanical filter, it can also absorb certain undesired chemicals, and then you will do a vacuum drying or low temperature drying or freeze drying, then you get the final dry product, and then you pack it as per requirement of packaging requirement, and then just apply to the end user. So this is all about penicillin. Now I'll discuss about one more antibiotic, but if you have any question on this, I'll just try to answer your queries first, then we'll go to the another antibiotic, a description of another antibiotic production. So anybody has any question on this?
None currently, sir.
Okay, thank you. File code is not working. File is working. Now we'll discuss about another antibiotic called bacitracin. So I have mentioned about penicillin because you produce penicillin using fungi, and mostly they prefer to have surface fermentation instead of submerged fermentation. So obviously, when you use surface fermentation, the transfer limitation would be there, and you will also have the longer incubation period. Like if you get effective transfer processes, then obviously number of amount of contact or the frequency of contact between solid surface and liquid reactant will be much more frequent, and you will get less amount of time for conversion. So rate of conversion will be higher when you have submerged fermentation compared to surface fermentation, surface culture. So we are talking about one of the important antibiotic mostly we use for surface wound, means like whenever you have any skin infection, or you can have any small cut in the skin, or post operation care also they use bacitracin to kill different pathogens. Sometimes it is also used to treat some diarrhea, because if you get some GI tract infection, like gastrointestinal tract, if you get certain infection and you get diarrhea, then also bacitracin is used. So the name of the antibiotic is and it is actually a polypeptide antibiotic. Now, mostly it works against gram negative as well as gram positive, but mostly it works against gram positive, but it also works on gram negative bacteria. And people prefer to use this medicine as a oral medicine, but obviously in some severe cases you can actually have the intravenous application also. But it has certain other side effect, like if you have prolonged use of bacitracin, it can create kidney problem, means it can damage the kidney. So mostly in human, it is used for infected wounds, like and also you can have different skin diseases like dermatitis or keratitis, different skin diseases. Dermatitis means these are all human application. Dermatitis, keratitis, and for animal again same thing, means infected wounds can be healed in animal also, and also with particularly cattle farm, they also use it for the cure of mastitis. So It is quite common disease in cattle farm. So bovine mastitis are also being treated by this. So it is for this kind of disease, but again, these are mostly different gram-positive and gram-negative bacteria. They create the infection, and then this particular antibiotic is used for treating this infections. Now, different bacillus bacteria. So I have earlier in penicillin we have mentioned about fungi, whereas in bacitracin we are talking about bacteria. So Bacillus subtilis is one of the common organism. Was sorry, Bacillus subtilis is one of the common organism to produce bacitracin, but the yield of bacitracin produced through Bacillus subtilis is not very high, and also the active ingredients, or when you talk about the polypeptides, because we mentioned about the polypeptide antibiotics, so here actually you'll get a mixture of different polypeptides. So bacitracin A, B, C, D, E, F, different polypeptides will actually produce different kind of bacitracin. So when you try to get more effective bacitracin, so type of bacitracin you can have A, B, C, D, E, F, G, different type of bacitracin you can get. Now, when you talk about activity against bacteria, there bacitracin A is the most active organism used, most active antibiotic used to inhibit or kill the organism. So in industry scale also, people always try to produce bacitracin, and when you try to compare their effectiveness, you will actually find A may be almost 5 times higher than the other bacitracins. Only problem is when you use different kind of strain, you can end up by getting different proportion of A, B, C, D, E, F, G. So it is very much possible that you are using a specific bacillus which is producing more amount of bacitracin A, then it is beneficial for the product. And if you have more production of say bacitracin F or bacitracin G, essentially you need to do little more separation, means you can say rigorous separation to get purified bacitracin A. So obviously process will become more expensive. But if you get say 80% A and or maybe 90% A and remaining polypeptides as the contaminant, then also it is possible that you are not going to separate them. You will just use it as it is without removing the other impurities, other polypeptides, because their effectiveness will be less. So as if they don't have any other side effect, you can still use it as a mixture of antibiotic, and you will get your desired performance because 80% of the constituent will be bacitracin A, so you can get good treatment. Now to get higher concentration of bacitracin A, one of the preferred culture is Bacillus licheniformis. So it is called Bacillus lichen licheniformis. So there you get higher production of bacitracin A. Bacitracin A when you use Bacillus licheniformis. So in the production process or in the industry, you will try to use Bacillus licheniformis and you will actually follow similar kind of step. You try to produce or you try to develop the inoculum in the smaller vessel first, then from there you will just go for higher vessel. And when you try to use the media, there also you have to make sure that you're providing sufficient amount of nutrients like carbon and nitrogen. And in some cases, they actually prefer to use a little bit of complex media like beef infusion. So beef infusion broth will have substantial amount of nitrogen as well as carbon. And it also has some benefit like beef infusion broth will provide sufficient amount of nitrogen, carbon, and also it will inhibit some hemolytic streptococcus. Because if you get any other impurities or any other contaminant, means if you have a chance to get any other contaminant, then also it will not allow the hemolytic streptococcus. Now, this bacitracin is produced in a similar fashion, like you have first you get the bacteria from soil, like Bacillus licheniformis from soil, and then they preserve that to after doing normal screening to check which particular strain is giving highest titer, and that culture is actually used for further production process. So first you grow it in a 4-liter flask, and here the temperature, optimum temperature is around 37 degrees centigrade. And in the first step, when you try to do it in 4-liter, you incubation period would be around 18 to 24 hours. So you can see the difference. In the earlier case, we are talking about surface fermentation, or you can say surface culture. There we are spending days, 3 days, 4 days, 5 to 6 days. Whereas here we are talking about hours, so less than a day. So it is actually done in submerged culture, and you can use different kind of medium. So means I'll just give some common example like krypton medium. So here you will have krypton, and then that beef infusion, and you can have soybean meal, because most of the cases you need to provide nitrogen as well as carbon. So soybean meal will give you nitrogen. You can have along with that you can have starch, and uh, for precipitation sometimes means at the end of the operation we also add calcium carbonate or maybe some calcium salt, say calcium lactate. So that is also added to the system because at the final stage you want to get a mineral salt, so you can get calcium salt by using either calcium carbonate or calcium lactate. And in starch, you can either use starch or other carbonaceous material like dextrine or sucrose. So essentially, you need to provide nitrogen and carbon in the system, and for precipitation, you just use some um, calcium salt. Now, when you try to grow means this bacillus in surface culture, versus submerged, you can see a significant difference. So if you try to grow bacitracin using same bacillus like Aniformis bacteria, then surface culture would take say 3 to 5 days, or even sometimes it can take, depending upon the media also. So if you have little bit rich media, it may take, or little bit more complex media, it may take little longer time. So mm, you can actually, it can go up to 7 days even. And the tighter you get, like when you talk about the yield, maximum yield could be around 90 Oxford units per ml. That is the maximum yield you can get after spending 7 days time. Whereas in submerged culture, this time will actually vary between 18 to 30 hours. And when you talk about yield, so this is for surface culture and this is for submerged culture. Yield you can get even up to 400 units OU Oxford unit per ml. So you can see the difference. It is say it is almost 100, so it is around 100, and it is 400. And the time when you try to consider, so average if you take 24 hours, so in one day you can get 4 times higher amount compared to the surface culture, and that actually happens because of low or inefficient transport. So inefficient transfer of mass, inefficient transfer of heat, everything will actually result in this productivity. So you are getting this much product per 7 days, whereas you are getting this much product per 24 hours or per day. Then when you grow them in 4-liter flask, so first you're growing them in 4-liter flask. Then you transfer it to say 150 gallon working volume, and reactor volume is 200 gallon. So again, it is aerobic, so you have proper agitation as well as aeration system, and mostly, as I mentioned earlier, also you need to use either glass line vessel or stainless steel vessel, which will not interact with the acid. So it will actually withstand this corrosive environment, and you do vigorous aeration, and obviously you try to maintain same temperature, like the entire process should be maintained at 37 degrees centigrade, and pH is near neutral, so around 7 you maintain pH, and again continuously you aerate to produce sufficient amount of biomass. There you keep it for 6 hours. So first in case it is 18 hours, to 24 hours. Here you keep it for 6 hours. And then you move to a seed tank, final seed tank, that is 800 gallon. And working volume, total volume is 1200 gallon reactor volume. And here you actually try to do this autoclaving of the media in appropriate manner, because I mentioned that you sometimes you add calcium carbonate salt. So when you do this operation, you don't mix everything together, because it is very much possible that if you try to sterilize the carbonaceous and nitrogenous carbon source and nitrogen source along with calcium salt, you will end up by getting precipitation. So you do the autoclaving of or sterilization of media component which will not interact with each other, and the remaining media component like calcium carbonate, if you are using, you just separately you autoclave it or sterilize it, and then at the final media when you get a room temperature or 30 to 70 degree centigrade temperature, there you add it aseptically, means you maintain aseptic condition so it will not get any contamination while adding it to the system, and then you add the seed culture. So first you prepare this 800 gallon media, or little less than 800 gallon, 150 gallon you actually are going to add to make 850. So it will be around 650 gallon media you will prepare, and then you just wait it to attain the room temperature or 37 degree temperature. Then you add the inoculum from earlier culture, and also you add the calcium carbonate or calcium lactate salt, that is also sterile, uh, through a separate line, and then you start your reaction. And obviously, in the process, you are supplying sufficient amount of air. So there also, you keep it for up to 10 hours, up to 10 hours. So it varies between 8 to 10 hours, and then you move it to the final fermenter, that is your production fermenter, which has a capacity of 24,000, double the amount. So everything is, and in the final fermenter, you will have proper control of temperature, pH, and everything, and you have sufficient aeration to get. So in this process, the liquid should not experience any anaerobicity. Anaerobicity should be avoided. So you have sufficient amount of oxygen present in the system, and then you get the broth. You filter it like the way we did for penicillin. You filter it through uh, vacuum filtration unit, and after filtering the liquid you get, then actually you do extraction using butanol. So here earlier we have used amyl and butyl acetate. Here actually you do extraction using in butanol. And then finally, that is the initial extraction. So extraction one, and then you do the second round of extraction using PBS, buffer solution. So it will get transferred to the aqueous phase then. And deliberately during this process, certain amount of zinc salt, zinc salt is added to get zinc tagged bacitracin, because zinc tagged bacitracin has higher potency, and also it shows more stability. So zinc tag shows higher potency and also it has higher storage stability. And when you use as animal feed, like if you don't want to use it for human use, when you try to use it for animal feed purposes, there too much of uh, purification is not needed. You can just have evaporation of whole fermentation broth, and then you just dry it, and after drying it, you add it to the other animal feed supplements. So for animal use, it is much more simpler. You need not to go for any such tedious extraction process. You just take the broth, because even the solid present in the after filtration, you take the broth, filter it, and then evaporate that to get solid bacitracin, and then you can just add it as a food supplement. Sometimes you can actually provide the digested biomass also, but most of the cases they try to get this filtrate and then add it to the animal fodder to get some animal feed supplemented with the bacitration. And for human use, you use this extraction, and then you uh, do after extraction you add zinc salt to increase the potency and also storage stability, and then you go for vacuum drying. And so after this, you go for vacuum drying for getting the final moisture-free bacitracin, and or we can say zinc tank bacitracin, zinc bacitracin, and that can be used for human, used in human clinical settings. So this is all about bacitracin. Now, in the last class, we have discussed about the assignment. I'll prepare the group today, and then maybe I'll share it with all of you. And you need to just prepare slides for group wise. You need to prepare slides for. Suppose I am making 7 groups, then you should select 7 different antibiotics, and each group will actually contribute to prepare slides for those 7 antibiotics.
So could you then allot every group a specific antibiotic, because there might be some confusions or.
I mentioned that in the last class also. You can have a common Google sheet where everybody can see the
Yes, sir. I can. Yeah, sir. I'll create that common Google sheet. Yes.
and then you can just put the antibiotic. Reason is, if I give you certain antibiotic, I can actually choose certain antibiotic which will require more complex uh, pathways. So one group may say that, sir, I have got a very easy process. The other group got really complicated process. I don't want to get into that, because obviously when you choose different kind of antibiotic, little bit of difference in process step will be there. So if you choose the antibiotic group wise, then at least nobody can blame me that I have actually favored one particular group by giving an easy task.
Fine, sir.
Okay. Anybody has any other question? Okay, then if you don't have any other question, then I'll stop here, and then next class we'll meet again on Tuesday. Tuesday is a holiday, I think.
Yes, sir.
So I think Friday we'll meet, and I think that Saturday will be working then. Okay, then we'll meet next week on Friday, and hopefully by then I'll finish evaluating all your answer books. So maybe I'll put the marks on modules, so each of you can see just your own mark. I hope all of you can access Moodle.
Yes, sir.
Yes, sir.
Oh, okay. Thank you. I'll do that.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Have a nice weekend.
Thank you, sir.
Thank you.